Modern industrial environments demand secure operations and real-time access to data at the edge. That's where Dynix and AnyLog come together. Dynix is an industrial cybersecurity and technology company protecting modern OT environments. Through its ICS 360 platform, Dynix delivers visibility, segmentation, identity management, and policy enforcement, creating a secure foundation for industrial operations. ICS 360 Fusion builds on this foundation by aggregating, contextualizing, and governing OT data from PLCs, HMIs, historians, and industrial applications. Fusion publishes this data into a secure, real-time edge data layer and unified namespace. AnyLog is an edge data platform company enabling decentralized, cloud-free data access. Its Edge Data Fabric virtualizes distributed industrial data into a real-time, queryable layer, allowing analytics, AI models, and autonomous agents to operate directly on live edge data without centralization. Together, Dynix and AnyLog deliver a secure, scalable edge environment where data stays local and insights are immediate.
Hi, everyone. It's our first time at ProveIt. We partnered at Dynix and AnyLog partnered to bring this ProveIt solution, problem, whatever it is to you. Dynix's problem was that we looked at is semantic drift. Semantic drift is basically when the meaning of the data at your plant floor changes over time. Nobody sees it, nobody understands why. So we're trying to utilize UNS to fix, to amend that, to actually make that semantic drift not so bad, if that makes sense. To do that, we use a lot of our products. So Dynix is an industrial PC software company. We do cybersecurity. We have edge nodes over here. We have an ICS Defender that's a firewall. And then we have a controller, an OT SDN network. And Fusion is what you're looking at on this board up here. It's pulling the data, and it's a data mover. And it'll pull all the data from your plant floor and show it up here in these different dashboards, which will show you the data that you're getting, if it's bad, if it's good, whatever like that. And AnyLog, we'll give it over to Mark. Mark is the guy at AnyLog that does all the edge work. The edge historian, the virtual edge.
Virtual edge historian. Yeah. So Jared, thank you very much for the introduction. My name is Mark Davidson. I'm the VP of Products at AnyLog, and we are an edge-based virtual data historian. So the basic premise of what we do at AnyLog is keep the historian close to where the data is generated at edge nodes. Instead of having to ship the data to centralized data stores or to the cloud to have a historian. So we treat the historian as one logical system that can be distributed over tens, if not hundreds or thousands of nodes, excuse me, tens or hundreds of nodes, but it looks to the user like one single system. The basic premise of how we look at this or how we describe it is, instead of moving the data to where I run the queries, let's move the queries to where the data is. So the more nodes you have in horizontal, the faster and more processing power I have to process queries across the AnyLog platform. We're also going to talk about UNS. Typically, UNS has been centralized primarily through MQTT. I have to ship my data to a centralized MQTT broker to add my UNS semantics to it. Again, because we're a distributed data fabric, we do it a little bit differently. We actually publish a blockchain policy that has the UNS in it. That blockchain policy is then seen by all the distributed nodes and processed independently of one another, so that data does not have to centralize and go. So those are the two things we'll talk about. We'll drill into more detail and show some examples in just a few minutes. I'm going to turn it back over to Jared, and he's going to show a little bit more about his product.
All right, so just to show you what Fusion is and what it does. So this is a flow-based software. This is actually pulling data from AnyLog's edge, these edge devices, and pushing it up to a UNS. That's what we're doing. Fusion is what's creating the UNS, pushing it up to that way. And it also will show you the dashboards for it as well. So these are the dashboards that were created that show that data from the edge, from AnyLog's side. And then AnyLog has a lot of ways that they can show the data as well. You can actually use any dashboards to show the data, but it's Fusion is very powerful. Fusion can talk to anything you want it to talk to. PLCs, databases, Ethernet, Modbus, serial, any of that Fusion can talk to, which is very helpful for a plant floor that has multiple different things out there that you need to talk to. But that's pretty much it for that side of it. Mark, you want to get in and do your whole...
Did you talk a little bit about the IoT PCs?
Yeah, these edge devices are are Dynix devices that they're industrial PCs, basically. They're Linux boxes that you can put anywhere and run anywhere. They are where AnyLog's data is stored at the edge device. And Mark can go more into that.
Thanks, Jared. I appreciate that.
Switch that over.
Yep. So I'm going to drill a little bit deeper into what AnyLog does in this environment. If you're familiar with the ProveIt data sets, there are two data sets that we've decided to process. Data set 1 we did was Enterprise B. Data set 2 we implemented was Enterprise C. The way we do it, again, is a little different than the way most people do it. Most people centralize that data. What we did, however, split the data between the 3 different nodes. So Chrome, Sub, Sum, and TFF processes are actually going to Chrome, Sub, TFF, and Sum. Those nodes also are processing Enterprise B, Site 1, Site 2, and Site 3. So that data is on completely separate machines, not on one machine, but we're querying it like a single machine. So I push out my query, that query then gets distributed through the 3 nodes. The 3 nodes will then respond to the query, send the data back to the requester as it was if one database was used. So one of the other things we talked about is distributed unified namespace. It is, again, we don't have to centralize the data to create relationships and schemas with UNS. So the way we do that is we implement it via a blockchain. And you can see here, Enterprise B, and we could drill in to any one of the sites. And again, Site 1, Site 2, Site 3, 3 separate systems, but to the UNS, it looks like one common setup. I could then pick any table that has data in it represented by the disk and query it. Drill into the metric, and we have the raw data coming in from the metric, okay? So it's pretty much that simple. A little bit bigger. The next thing I want to talk about is now that we've got UNS information distributed to multiple machines, one of the other things that we offer is the ability to connect to this data via an MCP server. That gives us some very impressive capabilities. For example, in Enterprise C, this is the Sub, Chrome, TFF, and Sum are the data collected by the 3 different machines again. However, that data is directly fed by PLCs. We haven't massaged it. What we did is I fed that through an LLM, Claude in this case, and it spit out an ISA 95 and 88 certified UNS for that. And if you notice, we're looking at the exact same data in two different ways. They both point to the same data, but I can look at it based on what the raw PLC is pulling out, or I can create my own relationships and view data at the same exact process. Finally, I'm going to show some of the other things that I can do with Claude. I've fed it a prompt, connected up the MCP to Claude, and I said, create a real-time overall dashboard for sub and Chrome and TFF processes, organized by shift and batch, list top 20 issues, and list downtime events, and calculate OEE. That was the entire prompt that I gave Claude. Pointed it to the MCP that's connected to these three machines with data on each machine, and said, go. This is the dashboard it spit out in about 20 minutes. You'll see it shows the current shift, the hours into the shift, the number of batches completed, the overall OEE. It broke it down by the three processes I did, what batch is running. You can see that it will refresh. I've got auto refresh on 30 seconds. It automatically calculated OEE. It shows the top 20 issues gathered from the PLC messaging of what's going on and how it affects OEE. It shows downtime and what caused the downtime and how it affected OEE. So all of that was done from that single prompt. The thing that's interesting, we solved a problem, how to decentralize data, keep it at the edge without having to move huge amounts of data. We solved a problem of how do we do distributed capability for UNS without having to centralize the data to get information in UNS through MQTT. We solved the problem by creating semantic drift, eliminating semantic drift going through their platform of Fusion.
Addressing
Semantic drift. Yes, thank you.
Yes.
We also do something quite interesting. The implementation for this, it took 2 days for us to set up, stand up, and load the software on these three machines and the switch and the firewall. That took 2 days. It took us about 2 hours to load AnyLog up and point to the southbound data sources that Dynix was feeding us. Once that was done, that was it. 2.2 days. At that point, we connected the MCP and started creating dashboards. Now, Dynix took a little more time because they also created dashboards directly in their platform. That took a little bit longer. But the MCP was spitting out a dashboard about every 20 to 30 minutes. So we're that quick. How much did it cost? I'm going to let you come.
I mean, these edge devices that you see here, MSRP is around $1,400 for the hardware of the device. And everything is a tiered level, right? So it depends on what you want. Basically, if you have a small site, it can range anywhere from $7,500 to $20,000. Medium site can be here. It's tiered. So the cost is actually not bad. I mean, and it totally depends on you, and we work with each customer to make it beneficial to them, cost effective to them. So
AnyLog works similar. It's a subscription price per node per year. For 10 nodes, it runs about $20,000 a year. So your upfront cost for AnyLog in an environment with 10 machines collecting data will be about $20,000 a year. I think we've answered our 4 questions.
I think so.
Please stop by our booth. We'll be here at booth 44. Also, we've got a workshop on Tuesday. I'd love to see you there at 2:15. Thank you very much for your time.
Thank you.